Joel and Linda in the evening.
So, in thinking about the thermal qualities of heat and heat transfer, I thought it would be interesting to look at how blacksmiths use steel. So, this is my forge, and I'm heating up this bar. I don't know how the camera's picking it up, how glowing it is. But
It looks about like
now,
whitish hot,
Okay.
as you would expect it to be as a camera.
Okay, so in real life, not in camera, terms, this is kind of a fairly bright orange, and it goes to dull red here, and then this is all dark, and so the heat slowly travels up the bar, but it's slow enough that I can hold this end of the bar with my bare hand. Okay, so the special qualities of metal that blacksmiths play with are that it gets malleable, plastic, when it's at a high heat, and thinking of the kind of form of the metal as like a cage for molecules. I guess what happens when it gets hotter is that the bonds between the molecules gets looser, and the molecules are able to be moved around. So when I'm forging it and changing the shape, the anvil is doing one side of the work, and then my hammer is doing the other side of the work. So I'll just put a quick point on the end of this bar. I'm going to come and have a close look one.
I can zoom it in.
So now that bar has a square tapered point on it, perfectly regular. But, so that can only happen because the steel gets plastic and more malleable as you heat it up. So steel can also burn. And
I've seen somebody do it before. It's a little bit frightening, kinda.
it just looks like a bit of a sparkler if you don't overdo it. So let's see what happens when we burn the carbon out of the steel. It turns into an ugly mess. We'll just burn it to the ground. So I just wanted to show you this as well as a. I know. It's a little added extra that's not actually to do with, phases of matter, but it's a weird thing of steel.
Yeah.
It turns into a sparkler when you burn it. So another thing with steel and various alloys of steel is that there's a method of laminating different steels together that's used been used to make blades for centuries. That's we call now Damascus steel, and it's actually where you bring. Here we go. Oh, nearly there. Is when you bring the temperature of a stack of sheets of steel to such a heat that it's almost burning. So this is burning. Can you see the sparklers come off that?
Not quite.
Can you see the sparklers in the flames?
A little
Is
bit,
the
yeah.
camera picking it up at all?
Yeah,
You see how that's sparking?
yeah,
You can see it more here.
yeah.
I'm trying to keep out the way of the cat.
Yeah, that's,
So-
yeah. Little Miss Pumpkin down here.
Yeah. So if you hit it, you'll see it's splashes around a bit because it's got so soft as part of the alloy is burning. If I hadn't forged it, you'd see that it ends up being a bit of a bubbly surface that bears the visual resemblance of having melted a bit on the surface. So anyway, that's just a little bit about forging steel, and I wanted to show you how bits of steel can get stuck together with old-fashioned welding. So this is what came before arc welders and electric welding. So this is what I've done here, joining these three bars together. I've actually done this in the forge with bringing them up to an almost melting phase transfer, phase change heat, to where the molecules are just buzzing around enough so that when you hammer these bars together, they actually exchange enough molecules to like lock the bars together, and that's called forge welding. So another example of it is in the end of the poker here. Can you see this started out as a folded back bar, but then by forge welding it here, I can continue to forge that element so that it becomes one unit. It acts as one unit. And you can always tell when steel is not actually welded together, because this part and this part would take on two slightly different colors in the fire. They wouldn't look like, I'm putting my hand behind it to try and get the camera to focus better. They wouldn't look like one piece of steel in the fire. So that's always a telltale that everything's the same color. Anyway, all right, so one last thing, and this is on silver. I have played with this technique called mokame gane. It means wood grain metal in Japanese, and it's a process of laminating sheets of different metals, non-ferrous metals together. So this is part of a billet that's been forged down. So this is the outside edge of a billet. This is the inside, where you can see alternating layers of copper and silver here. It's got a bit flashy on the outside. So basically, this is the outside of a billet, and I've alternated layers of copper and fine silver, and it looks dark because the copper is oxidized with the heat. So they laminate together, not with any outside additive, but just by bringing it up to a very precise heat, which I think was 1435 degrees Fahrenheit. And that's at a point where the silver particularly is, this is not sterling silver, it's fine silver. The silver is just almost getting to the point of liquefying, and the molecules will just exchange places between the separate layers of silver and copper. So you actually get a third layer that's created in between called the eutectic layer. So these are all slivers off of different billets that I've made over time. I actually start out with a square that's like 2 inches by 2, and this is a failure one, and I wanted to show you this because you can see here this got overheated, and you can see how much the silver really was made much too liquid to be useful, and then by overcooking it, it went past the point at which the heat bonding could happen. So this is what a failed billet looks like. But so this is the phase change of metal in very visual evidence here. And you can do this as a decorative process, and in jewelry this is called reticulation. So, I accidentally did a whole bunch of reticulation here. So anyway, that's it. So that's all I wanted to show you. Thank you.
Yeah, that's the right way around, never mind.
That way around.
Whatever.
Joel and Linda in the evening.
If we turn it over,